So it's been a long time since I'm going and providing some tutorial by using R because I'm attending some conference somewhere and there's many other job as well. And there's many physical event that I need to attend. So today, direct to the point, I show you how to do linear scaling bias correction by using R. This is for GCM. For people who are familiar with working with a climate model, we need to do a bias correction. One of the option for uh, improving our model for historical and future projection, we use bias correction. And one of the common method is linear scaling. And this time I will show you how to use how to using R. You can do this linear scaling, and the one that we use is multiplicative. So I will share the screen now. Okay, let's go straight to R code. Okay, so you can install this library, but I don't know. Actually, you don't need to install this library. I'm just concerned that maybe because this is I have another code that I use for linear bias correction that I show in the previous video that is very extensive that use a clean down approach, but this one is more on the manual one. You can prepare this one by using this code, prepare this code. But this one is specific by using linear scaling bias correction because a lot of people use linear scaling, and linear scaling is found to be very robust, very good in addressing systematic error in GCM, so that it can be used for bias correction. So linear scaling bias correction for this one, we this is how we calculate linear scaling for based on multiplicative. So the scale factor, we use a standard deviation of the observed over standard deviation of the model, and then we apply this scaling factor to the model and with the scale factor. And then this is the function that we prepare. And then now we load our observed data. So we unit of your observed data. In this case, we have this chips rainfall data. So this is our working directory in the, let's see, because I prepared this one for my friend. Actually, that she has trouble with one of my code that was very extensive, and somehow in her case, the data distribution is very different from in Malaysia, in Iran actually. So we need to address this case differently by using this method. So our data is for observed data. We use chips data rainfall graded data. So chips Iran here. So the data looks like this. So this is chips rainfall data. If you're familiar with chips rainfall data, you can download and based on my tutorial last time. So you have year, month, and day. And this one we do bias correction for daily data. This is for rainfall data. You can see this rainfall data from 1981 until 2014, and it's have 155 grid point. So this is how we arrange our graded data for observed data. So now we run this set working directory, read our observed data, and read the data to read from 1981 to 2014. And then we load our climate model. So we have SSP1, SSP2, SSP3, and SSP5. So this SSP is 126. Okay. For example, I show you how the dataset looks like. It's similar. The arrangement is similar. You have year, month, and day, and then grid point from V1 until V155. Yeah, so for projection, we have 2015 until 2100. So you can download the GCM. I have provide tutorial how to download GCM. You can refer for that one. So this is the GCM that we use. So for each of the GCM, we load the climate model here. So we have four GCM here, four scenario here. And the GCM that we use, that we found, the one of the best is CMCC ESN2. So we use this model and we download this four scenario, and the data will look like this from 2015 until 2100. So this is the raw GCM. We want to bias corrected this raw GCM by using linear scaling. So we read this data set. So we have uh, in our folder, you must have your SSP1, SSP2, SSP3, and SSP5. So you run this one. Okay, now you run everything. It takes some time because the data quite high. Now you load the historical GCM data. So this is also very important. Every GCM, they have also historical data for bias correction, especially if we want to do validation, we must validate the bias correction GCM historical one with the historical chips rainfall data and the raw GCM, so that we can compare. Does the GCM bias correction method improving the GCM or not? That's why we must have this historical GCM also. So this is the historical GCM is the same also. The arrangement is the same. So we have historical GCM from 1981. It must be similar with the historical dataset until 2014. Similar with CHIPS dataset. So arrangement is similar, year, month, and day from V1 with until V15 grid point. So that is our historical GCM. Now we extract coordinate from column names. So we extract the coordinates here by using this code. You know, we have the coordinates. So you extract the coordinate here, run, and the coordinate is actually extract the same grid point for GCM up here, all the same for projection and for observation, so that it will do bias correction correctly, and then we match a grid cell between observed and model data for all model, so we can match the grid point with the model. So if you see some warning here, you can just ignore it. So there is nothing wrong with it. This is just okay. Nothing wrong with it actually. So you can use this to match the grid cell with the observed and model data for all models. And then you match it by using this code. And apply observe coordinate paste, all this code you must run it. You can run this one. So nothing's wrong. And then after you do the matching of the grid point by using this code, you can copy this code, watch this video and copy this code, and then you perform linear scaling bias correction for all models. So we do directly for all models, not just one by one. So I make this code to apply all the bias correction model to this project different SSP just now. And also historical. I want to do correction the historical, so historical GCM. So this is the input data that we have just now, which is here for projection for different scenario and historical GCM. So I uh, perform this linear bias correction here. So you can see you can use this code and run this one, and then it will run everything, and then you can paste your result. Oh, I can maybe put it down here. Okay, so everybody can see it. Okay, okay. Then you can write this one and write this code to write the corrected model to CSV file. So you can run this one. So it takes quite some time, but not too much actually. So it will run and you will have your result for uh, CM for SS for bias corrected 126, bias corrected for SSP 245, bias corrected 370, and bias corrected 585 scenario, and also historical GCM. So it will be corrected based on multiplicative linear scaling. So it's finished. So you have all the result here, multiplicative. So additive is not there. So you have this multiplicative, for example, this one. So this is your result. So you have year, month, day. You see, it's kind of a mess here, but it's actually from uh, 2015 daily, daily data until 2100. So it's matching. You see, it's matching. So you can just replace year Monday with the real date, but this is the bias corrected model. So all the model has been bias corrected here. So you can use this bias corrected model for future projection. And for historical one, you will get this one. So this is the historical one. You can correct this month is wrong this year and wrong this year. Actually, it's from 1981, right? Year, month, and day. You can make a correction for this year, month, and day anytime you want, because I didn't make a correction for this one in the code, but the result is okay. This is the bias corrected historical GCM for CMCC ESM2. So you can use this one to check if this bias corrected model is improved or not compared to the raw historical GCM. So okay, I think that's all for today. For how to do linear bias correction based on multiplicative method. Okay, thank you for watching. Hope this will be very helpful for you.